everybody, this is Turing Supreme, and here I'm going to talk about Turing. So we're getting really close to being able to make games now, so I'm going to review a game given to me by a friend, and I'm going to explain how it works and what it does. So before we look at the coding of it and the programming of it, let's play the game. So this is the startup menu of the game. This is Brick Breaker. Move left and right with the arrow keys. Bounce the ball back at the bricks to win. You have 3 lives. Press any key to start the game. I like how they use a different font and how they made it bigger. So let's start. I'll move my mouse out of the way. So yeah, it's very slow. That's mainly because I'm recording right now, so it's kind of slowing down the process. So let's talk about it. So right now we have, the basic stick, the ball moving around, and the bricks. When they break, it actually works. It actually breaks. So as I can presume, the higher up the bricks go, the more health it has. So the red ones at the bottom can break with 1 hit, and the orange ones can break with 2 hits, and the yellow ones can break with 3, and then all the way at the top, the gray ones can break with 8 hits. So yeah, right now I'm just playing some good old Brick Breaker. I like the creativity here. So it's very basic, just basic Brick Breaker. I'm gonna die, see what happens. My life meter went down to 1, and I respawn. I have the same amount of points. Round 1, why is it saying 1? And then multiple rounds? Well, this is a slow game, so I don't know if I'm going to be able to beat round 1. So I'll just die 3 times, see what happens. Another screen comes up, you lost, play again. Sure, let's play again. Level starts up, I'm back at 3 lives, or 2 lives, and I have no points. I'm still at round 1. Alright, so now that we've got enough of the game, let's see how the program works. And this is a very large program. 1,145 lines of code. Okay, let's see how this thing works. Okay, so the view.set at the top is setting the screen. So it's saying, alright, the graphics, the size are going to be 800 pixels by 650. As I explained, 800 is X and 650 is Y. And the title is Brick Breaker, of course. The position is center, and then we have no cursor. What does that mean? Well, that means when you type, like when I was pressing, like, play again, yes, when I was typing the Y, there was no cursor like this, like there usually is, just a thick line. So, it got rid of that, which I think was pretty intelligent. Okay, so we have a giant block of commenting, probably to indicate levels. So, procedure to draw bricks. Okay, so that's a procedure to draw bricks. Whoa. There's a second one? Hang on. There's a third one, a fourth one. How far does this go? I'm gonna go down, see how far it goes. Okay, other. Okay, so it's starting to move. 11? There are 11 levels on this game. No wonder why this program is so big. So let's talk about how this works. So we have 5 arrays of unknown value of integers. Then we have a variable called numBricks and y time. So let's first discuss how this is going to work. So right here in the procedure, it's declaring the first value of the arrays. So it's the first brick, I'm going to guess, it's going to start at the very left. It's going to be at around 400. And the second x is, like the second part of the brick is going to be 100, and the second part of the y is 420. So it's going to be 20 pixels thick and 100 pixels long. The color is 12, which I said is red, and y time is 390, and numBricks is 64. So I'm going to guess this means how many bricks are going to be on screen. Y time, I'm going to see what that means later, see if it pops up here. So it says for I1 to numBrick, so 1 to 64, it's going to draw and fill a box, and then it's going to draw the outline of the box with the black color, 255. Oh, so right here is for the like when it reaches the end of the screen, it's going to go to the next row above. So it's going to add 20 for the y value, and x, the next like the next array value of x and x2 is going to be set back to 0 and 100 like it was at the beginning for the, so that it starts at the very left again. Oh, so now it's doing the color. So it was 12, so now it's going to be 42. And then the next time, oh, it's 42. So it's going to go to red, then orange, then yellow, then green, then sky blue, then blue. Then I think this was purple. Yeah, it was purple. And then this is gray. So this right here, else if I equals numBricks, then so this, right now, we may not know what this means and why it's there. So right now, we're going to leave that be. And then the else statement is saying, okay, so the next y values and c's values are going to be the exact same, because it's saying y, I, like counter plus 1, equals y, like the current value. And then the next x value is going to plus 100, add 100. So then these procedures over here and other levels, let's go away from that. Okay, so other. So now we have left. So this I'm gonna assume moves the paddle left. So we have CX. I'm gonna assume that's controller X, and then controller second X. And then we have controller Y and controller second Y, and then controller color. So right off the top, it's gonna delete the paddle by making it 255, which is the background color. As we saw when we were playing the game, the screen was black, and then there was the paddle and the bricks. So CX is less than or equals to 0. So what this means is, if the paddle is at the very leftmost part of the screen, then there's no script to run, so nothing's going to happen. And then otherwise, the x values are going to change by -2. And then it's going to redraw the box. So all this means is it's going to erase the box, then say if it can move any more to the left, and if it can, it's going to move left. And it's basically the same thing for right. So draw fill box, it's going to erase it, then it's going to say, okay, is it at the right? It is. Okay, nothing's going to happen. But if it's not, it's going to change by adding 2 to the x value, and then it's going to redraw. Now you're probably wondering why the CX and CX2 have var before them, but CY, CY2, and CC don't. Well, that's because CY, CY2, and CC are not going to change at the end of the procedure, so there's no point and making them variables. Okay, so now we have break bricks. I'm gonna guess all these extra colors are for the next rounds when they add more health. So this highlighted area we can ignore. So right now it erases the box by, again, doing the same trick, making it black. So then it's saying, okay, to give it health, if the color is gray, then it's going to change to purple, and your points is going to increase by 50. And then if it's purple when it breaks, it's going to change to blue. Your points are going to increase by 40. It keeps going down. 42. So 42 is the second last color. So when it turns to 12, the next time you hit 12, what it does is it moves the X values and the Y values to the bottom left corner, and it changes the color to black. This is so that the bricks don't have any contact with the paddle ever. And then number bricks. Okay, so there's two variables now. Number bricks subtract equals 1, and then the points adds 100. And then at the end, it's going to draw and fill the box, and then draw the outline again. Now you're probably thinking, why would it draw it when it's erased? Well, because when it's drawing it, these X values and Y values, they all equal 0, and C equals black anyway, so it's going to be visible. Okay, so now we have the stats, the statistics of the game. So we have our points, lives, count, I'm going to guess is the level, and then score font. So this is how you do fonts in Turing. Like how I commented on how nice the font was. Well, so this right here is drawing a box that fills the entire top area. So that means that that's basically just erasing the statistics when it changes. So then it's going to draw lives. So what it's doing is fonts.draw, then bracket the string that is going to be typed, comma, then that X value, which is long. So basically, this round is rounding this entire equation to the nearest whole number. Because it's an integer, it has to be an integer because there's no decimal of pixels. So it's just an equation to put at the left corner. And then length counts the amount of characters in a string, and int str changes an integer to a string. So lives is a integer, so it's changing to a string. So if you had like 20 lives, it would count the length as 2. So it would change where lives is, and then subtract 150. And then max y minus 40, like this is the y value. So it's going to be, I'm pretty sure it was 650, that was the maximum y value. Yeah. So this is going to be 610. They could have just put 610, I don't know why. And this is the font they're going to use. And then this is the color. 0 is white. And then the same exact thing, but it's moved slightly less. Like this is subtract 150, this is subtract 50. Because this time it's printing out the amount of lives. And this is going to change the integer to a string. You need this because otherwise it won't work. It'll say wrong type. And it basically works the exact same for the rest of it. Okay. Procedure ball move. Now what is this? Well, because there's so many variables they wanted to move, the programmer wanted to move it to the next line so that they didn't have to extend all the way out to infinity. Okay, so we have a lot of variables here. We have ball x, I'm guessing it's the x value, ball y, and then xd, yd, xa, ya. We'll see what those are. Number bricks, points, lives, count, times 2, y time. Oh, maybe we'll finally figure out what y time's for. Score font, the font. Why does it need all these variables? Okay, well, we're gonna find out. So right now, right off the bat, it's going to erase the previous ball by making it black. Now, like I said in graphics, the ball x, ball y, that's the center point of the circle. And this is the x radius, and this is the y radius. So I'm going to guess it's a predetermined value, which is why it's, again, doesn't have the var in front of it, like the rest do, because it's separate. So I'm going to guess that means it's not going to change. So now, this whole statement right here, if ball y minus 10, so this means the bottom part of the circle because the y radius is, I'm going to guess they made it 10, so it'd be more logical to put ball y2 here as well, so that if they want to change the radius later, they could do that. But anyway, so this is saying if it's greater than or equal to 10 and it's less than or equal to 30. So I'm going to guess that means that's where the paddle is. So then there's another if statement inside saying, okay, so ball x is greater than or equal to controller x and ball x is less than or equal to the second controller x. Okay, so this means that, okay, so now it's met this point of y. Does it equal the x values of the paddle? Okay, it does. Then yd, I'm gonna guess that's the direction in the y. So if it's going up or down, I'm gonna guess when it's 1, it's going up. So what is this? So I can assume that yd, since that's direction, I can assume that for xd as well. So ball x. So this is basically dividing it up into like how many? 1, 2, 3, 4, 5, 6, 7. This is dividing it up into 7 different, like, almost equal parts of the paddle to say, okay, is it going to move more to the left, more to the right? So I'm going to guess XA equals the amount of pixels it's going to move to the direction, and XD I'm going to assume means it's going to the left because it's at the left part of the paddle, and at the other side it changes to 1. So here it's basically saying if it hits nearest to the center, because it's 100 pixels thick, the paddle, or 100 pixels long, that X amount is going to change to 0. So now that we have this basically is what I just told you. It says, okay, is it going to move to the left, to the right? So now that it has that, this right here, this little bit of code right here is basically saying, okay, does it hit the top of the screen? If it does, then it's going to go the other direction. And then else, basically, this means, okay, so there's no other case, so that's it. Now this basically is the exact same thing. If it hits the edge of the screen, like if it hits the left, it's going to move right. If it hits the right, it's going to move left. Okay. So now we have this if statement right here. If ball y plus 10, so the top part of the ball, if it equals y time. Oh, I get what it did now. Okay. So right here, it's basically making a for loop for the amount of bricks drawn. I'm gonna guess that's the difference between num bricks and number bricks, because num bricks is how many bricks are drawn, and number bricks are how many bricks are not broken yet. So right here it's saying if it equals like in between, if the x value equals the same x value as the first or whatever brick, then the same thing for y, it's got to make sure it equals the y value too. Okay, so the direction now is going to change to down because it hits the block. Oh, wait a minute. Right here, I forgot. This is saying if it equals y or y plus 10 because the bricks are 20 thick. So it's going to be like this. Then it calls these procedures. So now this is the reason why these variables have to be variables, because that's how you call them. You call the variables into the procedures. And this is saying that if it hits like the very leftmost edge of the brick, then the direction changes to the left. Oh, sorry, if it hits the rightmost, it's gonna move the opposite direction it was moving, so that it goes away from the brick if it hits the edge. And the same thing for the other way around. So now that we have this part, it's basically saying, okay, now is it going to hit the upper part of the brick? Okay, so if it does, then the direction is going to go up, not down, because it's logical that if it hits the upper part of the brick, that's why if you go at the top of the screen and it's bouncing up at the top for 3 points, it keeps bouncing up and then down, up, down, because it keeps hitting the top of the screen. Calls the procedures again, and does the same exact thing for the edges. So now we get to see what this means. So if xd equals 0, then, so this is times 2. I'm going to guess that's a counter. So if it equals 1, then it's going to equal 2 the next time. So if it equals anything else, then the x value is going to change by the x amount. So let's go back up to this part. So if it hit the very left and the x amount is 3 and the x direction is 0, then too far. Then it's going to move to the left by the x amount. I'm going to guess the reason why they did this times 2 counter is so that the paddle can move faster, because the max it can go is 3, and that's every other time, whereas the paddle itself can move 2 times to 2 pixels every time, so it can move faster. So the next xd, if it equals 1, then it's going to move to the right. Basically the same deal with the counter. And then there's no counter for the y, so if it equals 0, then it's going to move down. If it equals 1, it's going to move up. So it's basically changing, like the same trick with the moving left and the right of the paddle. It's changing the x value so that it can move. And then at the end, it's drawing the oval. So that's the end. This guy loves making large blocks of commenting. I don't know why. Maybe so it's easier for him to see. So then we have our variable declarations, and here is our font, like a score font. We have a score font equals an integer, which equals font.new, which is a new font, and then the name of the font, then colon, the size of the font, colon, then is it bold, italicized, is it underline? So we made it bold. So now he's doing the same trick with the stats. He's drawing the font to make the beginning screen. So that's good with the title font. Then get ch, and then there's a variable ch which equals a string, and then bracket 1. This means that the string is going to have only one value or one character in it. So get and then ch just means get character, and then bracket which variable, so ch. Then when that happens, it's the same deal with get. It stops the program until it gets a value. So then it sets the screen as no cursor. Might have forgot to delete that. So CLS means clear the screen. So it's going to clear the entire screen. Then it's going to draw and fill a box from bottom left to top right. Corner is going to color it black. Make the background black, and now it's giving all these variables values. So times 2 equals 1, so that the counter works properly. And then these directions are all set to 0, and the amounts are set to 0. And then the amount for y is 1, so that it starts moving down. And yd, since it's 0, it's going to move in the direction of down. So this, I'm going to guess, means about the center of the screen, the x value of the ball, and then 200 in the times. So now it's going to draw your paddle, and I'm going to guess counts the level, so it's just saying, okay, there's 64 number bricks. There's 64 bricks in the level. So there's 11 levels, so yeah. So it's gonna draw which level equals which. So then there's a little delay, and then it does the stats. It prints out the stats, and then here's a loop. Here's the loop of the main program. Now input.keyDown, and then bracket controls. Controls is an array char of Boolean. If you want to see, controls right up here, array char of Boolean, because that's the type of variable you need for input.keyDown. My scrolling is very slow today. So this is going to keep looping even if you're not like inputting a key. So then now it's saying, okay, if you type the left arrow, then it's going to call this procedure, and the exact same thing for the right arrow. Then enter. Oh, here's a pause feature. It didn't even say that in the startup screen, I'm pretty sure. So it delays, and then the same deal, it stops the program until it gets a value for character or ch. So this delay, I'm pretty sure, is basically enough time to let go of the enter button. And then otherwise, if you're still holding it for some reason, it may unpause. And then ball move. Okay, here's a long list of variables because it needs all these variables to move the ball for some reason. And I explained that about early in the video. So now it's just drawing the paddle again and the ball again, and then it's updating the screen, and then it's drawing them another time, and then it's updating the screen. And look, CC equals 0, so that means that it's white. So they just drew it twice and then updated the screen. That's why it was so slow. So now it's saying, okay, if the ball ball y minus 10, so the bottom part of the ball is less than or equal to 0. Then now it's setting the lives amount, so it's basically just erasing the paddle and the ball, minusing 1 life, subtracting a life, and then resetting the exact same ball values and the exact same direction values, and the same exact x values for the controller, and then it's delaying a second to give you a little bit of time to think, okay, I just died, or I lost a life. Then it's redrawing your thing, and then it's redrawing the stats so that it can update, okay, there's 1 less life. So if it's not greater than or equal to 1, which means if it's equal to 0 when you touch the bottom of the screen, then it's going to exit the loop. Then it also says exit when number of bricks equals 0, so exit when there's 0 bricks left. So the end loop, close the screen, then if number of bricks equals 0, so now it's just saying, okay, so why did it exit the loop? So number of bricks equals 0. So then it says, congratulations, you beat it, you want to go again to the next level. Then it's looping to get character. If it equals y, then it says yes, so it's resetting the point. It's adding 1 to the count, so that it goes to the next level. And lives equals 2 again. It's clearing the screen so that it can type, okay, let's go to round 2 now. So it's delaying a second, and then it's going to loop back because the whole thing's in a loop. Then it's like, okay, so did the loop end because ball y is less than or equal to 0? So then it's saying you lost, you want to play again. Like I showed you, I lost. Then it'll restart with the points and the lives set back for you and clearing the screen. Alright, let's go again. And then if you said no, it's going to exit. Like above, if you said no after you beat a level, it's going to exit. And then it says, so this exit right here is for this loop. And it works the same with over here. So we need another exit statement over here with a main loop. Exit when ch equals no. When the person typed no, then it's clearing the screen and says, I hope you had fun. Well, I did have fun playing the game. Alright, so now that we've kind of ran through that, I'm going to answer some more questions. So one of the biggest questions you're probably wondering is, why is there 2 variables for number bricks and num bricks? Well, that's because if we made it 1 variable, that means that every time you broke a brick, it would subtract 1. But the computer doesn't exactly know or care which one you broke. So in this loop, in the moving of the ball procedure, when it's going for I1 to num bricks, if you broke like the first 8 bricks, so now num bricks equals 56, and it won't count the top ones, which means that you can't beat the level. So that's why they needed 2 different variables, so that, okay, so there are 64 bricks, but then when they break, they're the left corner. So this is so that when it's going, it goes through all the bricks, even the bricks that are broken, so that it doesn't cause any glitches. Then number bricks is just how many bricks are not broken. So, what else? Y time. Why is Y time needed? Well, so let's go above to the drawing. So it's saying, so the first Y value is 400, so the bottom the most bottom part is going to be 400, and y time is 10 less than that. Y isn't at 400. That's the programmer's reasons. Probably to get rid of glitches because he might have found a glitch. So y time. So let's go back down to the ball move. So this whole number bricks for loop only happens when the ball y plus 10, the top out of y, is greater than or equals y time. This gets rid of processing power, because it's running this entire thing 64 times every single loop, and every single pixel you move, or everything, even when you don't move. So it's running this 64 times. So it's like, okay, his computer might have been really slow, so it was probably lagging a lot. So he's like, I gotta find a way to make it lag less. Oh, what if I run this script only when it's above a certain point? So that's why he created YTime. So, as you can see, there are a lot of variables here that they used, and each one has a use. So, now, here, one more thing. Why does it draw it twice and update it twice? Well, that's probably because when it was moving, it was probably like glitching up or something. So let's see. When we run it, it's going really slow. Why is it going really slow? Well, that's because it's updating twice. There's no delay, it's just updating twice. So, let's get rid of one of these and see what happens. Move slightly faster. It's glitching up a little more. It probably glitched up more on his computer, so now, to prove that this glitches up if it doesn't update, let's get rid of this. Now let's see what happens when we run it. See how fast it went? The viewing update is basically like its delay, and it's updating the screen. So let's go back and add this again. So you're probably asking, okay, why does he need to redraw it? It's already in the procedure. Let's see what happens. When you saw it hit the panel here, I'm going to pause it. When you saw it hit, it made a little mark right here. So he probably redrew it to get rid of that little indent. So all of the decisions this programmer made is probably for the best, because maybe he had reasons to do this. So that is a rundown of Brick Breaker, and I like to call this game really fun because this game is very creative and it's very cool how they made 11 levels. So let's see what the other levels are like. So if I change the count, it's gonna go to a different level. So let's see what level 2 is like. Oh, it has. Oh, I see. It has two different colors for more health, because there are 10 different. There are 10 rows now. Before there was 8. So I see why. So now, here, let's go all the way to the last level. Let's go to 11. Oh my. Let's take a look at this. Okay, so those 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16 rows. Let's see how many bricks there are each row. 6, 8, 9, 10, 11, 12, 18, 19, 20, 1, 2, 3, 4, 5. It's about like 32, so that's like 512 bricks. And I can assume that these have 16 health, these have 15 health, so this is a long game to beat. So yeah, it's a nice game. Overall, what would I review this game? It's good. If I was the programmer, I probably would give it this extra update. And there was something else that caught my eye. First of all these comments, when I'm done making the game, I'm going to get rid of them. Because I don't need any comments that big. Because maybe that programmer put that so it was easily viewed in his mind. This was it. Ball x plus 10, ball x plus 10, ball x minus 10, ball y minus 10. Now, what if they wanted to change the value of the radiuses, the radii, if you will, of the x and y to make it a different size? Okay, so it's 10, and they put 10. Well, for right now, it's fine, but if they wanted to change this to 20 or 5, it would still only work if it was 10. So I would put, like, for ball y, I'd probably go ball y2 here, but that's the programmer's decision. He probably knew, okay, I'm not going to change it, so there's no point of putting ball y2 there. Another thing that caught my eye over here, I think this is, yeah, I see the error here. So, this is okay. This is if the left part of the ball hits the right edge of the brick, it's going to change direction. But if it hits the leftmost, if the right part of the ball hit the leftmost edge, well, x2, for what I've seen, is the right side. So maybe it's just a little glitchy with probably rushing. It should be just x, like that. And then the same thing over here. So these are what I would change of the program. Another thing I would probably do is, instead of making 11 different procedures for making the levels, I would probably make one procedure that has some repetition to it, like maybe every level it increases by a row or something like that up until a point where there's a max level. Oh yeah, that brings me to another thing. All the variables they declared, everything, they don't have a max level variable. So when you reach round 11 and you beat it, it's going to ask, okay, you beat round 11, do you want to go to round 12? Okay, let's go to round 12. And then when it goes to draw it, there's no script, so it's just gonna do nothing. And then in here you're gonna get confused because there's no bricks and it's doing all this stuff all over again. So overall, this is a good game. Programmer needs to do some tweaks on it. So yeah, it's big, 1145 lines of code. Usually a lot of games in Turing usually don't have that much lines of code because Turing is not powerful, but very addicting. I like it. And once I stop recording this video, you might get upset that the game is going to be normal speed because I've played it before and it's a normal brick breaker playing speed. Versus now, if I play it with OBS running, it's slow. It's really slow. So, thank you guys for watching this game review. If you like, you can subscribe to my channel. This is Ogini Supreme logging off.